Okay, so this is module 3. It's about protocols and then the models. Protocols and then the models. So within the protocols, we are going to look at the rules. And then still, the protocols, they do not actually, that the protocols are not stand alone, that you have to use just a single protocol. It has to be a protocol switch or combination of protocols. For you to have a successful communication. So it's what you're going to go through. So these are the areas that you're going to cover. We're going to look at the rules, then the protocol suite, standard organization, reference models, data encapsulation, and then data access. So the objective here, the objective is just to explain the role of protocols and then standard organization in facilitating interoperability of network communication. So the rule here we have a video. This video will explain the protocols that devices use to see their place in the network and communicate with other devices. So there must be the rules, must be the protocols. The protocols are a set of rules that are used to identify devices on the network, mostly to locate the devices on network and how the devices do communicate on the network. So network can vary in size and complexity. It is not enough to have connection. Devices must agree on how to communicate. So you having connection is not enough. I can give example that right now, yes, I have the connection. My phone using USB connected to my laptop. That is a connection. So I have to go ahead and activate my data. I have to go ahead and select the option for USB tethering. So if I don't, those are rules. Minus those two options, then my devices, they won't work. Those are the rules. And like I said, that the rule, it works, most of the rules, they work with other rules to achieve successful communication or to achieve the target. So as you can see, activating your data and the data, it has to be there, meaning that you have to subscribe, point number one. If you don't activate the data, yet you have already subscribed, you have your data there, it's not going to work. If you don't go for option USB tethering, your data is activated, you have data, still it's not going to work. So there are three elements to any communication. There must be a sender, there must be a receiver, there must be media. So right now, I don't know who is the sender and who is the receiver, but our devices, there are n devices on the network, your device and my device. But every time in the communication, there will always be the sender, there will always be the sender, the receiver, and then the media. Let me just give you an example. I'll use you, Anita, here. That every morning you set off, you have to go for work. This is your road from your home to the place of work. So you're from home to work. So this is the source. And this is the destination. Because you're from home and heading to work. In the evening, you have to report back home. Do you think that your home will still be the source, and work will be the destination? So this time it's going to change. This time it will be source, the work, the place of work, it will be the source, and then the home, it's going to be destination. So there is no any device that is mandatory that this is the source, and then the other one is the destination. The direction, it's the one that determines which one is sending and which one is receiving. So if it is receiving, it's a destination, and then the sending, it is the source, that way. So it's a must in every communication. There must be a sender and then the receiver. Like right now here, I'm the sender, you're the receiver. And when time comes and like maybe you're putting a question, you're replying a question, whatever, you will be a source, I'll be the receiver. So communication protocols, all communication are governed by protocols. There must be a rule. Like right now in our communication, there are rules that are governing us. And not only a single rule, there are so many rules that are there. Between us, we human beings, there are rules, and even when it comes to the devices that you are using, still there are rules. See? Protocols are the rules that communication will follow, and these rules will vary depending on the protocols. Will vary depending on the protocol. Like right now, between us, me and you guys, we have the rules that are governing us. Immediately once you receive a call, there will be other rules that will govern between you and even the other opponent. So the rules, they can't be the same. They keep on changing. I will give an example. When you look at this is a laptop and the desktop. Do you think that when this laptop is to communicate with the phone here, do you think that the rules will be the same? Yes. The rules won't be. They won't be the same. Huh? They will actually change, because now here the gadgets have changed. They will have actually the gadgets will have changed. So rule establishment, individuals must use established rules or the established rules or arguments to govern the communication. So when you look at the two paragraphs here, the first is difficult to read because it's not formatted properly, but the second shows the message properly formatted. You can actually check through that. Even when it comes to the way we communicate, as you're communicating with your friends, so it's not the same way. When you're communicating with your immediate friend, the other side, there are those that there's the way you phrase the statements and blah blah, and then even other people, still you have to, or you find it helpful that you are needed to change on the format. So all that, it's because of the rules. So protocols must account for the following requirements: an identified sender and receiver, then common language and grammar, speed and then timing of delivery, the speed and then the timing of delivery. Then we have what we call confirmation. So the protocols, they have to identify the source and then the destination. The grammar, the language and grammar. Then the speed, when it comes to application, there are those ones that tolerates delay. There are those ones whereby they do not. And then even the timing, the timing of delivery. That every time there is maybe the source destination, the destination has received a message, there must be the confirmation, the acknowledgement, the notification, all that. So common computer protocols must be in agreement and include the following: message encoding, the way right now we are trying to exchange messages, but between the devices, the message is encoded, formatted. It is encoded, or it is changed into format that is going to be uh, actually understood by the devices that are in communication. Then message formatting and encapsulation. The message, it has to be formatted. The message, it has to be designed in the way that it will be easy for the devices to understand that message, and that it can be easily moved from source to destination. Message size, that the message, it has to be in size that can be actually managed or handled by the participating devices. The devices. So most of the time I always use the example, the message size. That, because remember, we have the source, the destination, but still in between the source and destination, there are other devices. So the capacity of those devices, it can't be the same. So between point to point, from A to B, the A and B, they have to agree together what those two devices can actually receive, what they can handle. And even from B to C, still the same. They have to keep on agreeing. So there has to be what we call message size. Then message timing, when to send, and in case of anything, what should happen. Is in case, let's say, message has not reached, what should happen. Then message delivery option. How are the messages going to be delivered? Is it one-to-one? Is it one to group? Or it's one to so those are the network protocol requirements. There are five of them. So encoding is the process of converting information into other acceptable form for transmission. Then message formatting and encapsulation, that message, it has to be addressed. It is formatted in a way that it can actually be easily moved from source to the destination without actually getting lost on the way. So when a message is sent, it must use specific format and then the structure, that each and every bit that is sent on the network, it has to have the source and then the destination. That's the reason why you're seeing here, we have this. I don't know whether it makes sense to you guys. Look at this, that this is a message. I don't know whether you guys used this mode. That this is a message, this is the destination, and then the message, we have the sender. Now, we have what you call encapsulation. The encapsulation, it's like, I always call it wrapping, that our message, it is wrapped. You will not use the transporter, you will not you will not tell exactly what is inside, but the transporter will tell that this is the sender and this is the recipient. And then even the authentication to indicate that this, it is allowed on the network. So as you can see here, this is an envelope. Wrapping a message, and this message, it's going to only be read by receiver, but the transmitter will actually look at this, who is the sender and who is the Are you allowed, is this message allowed on the network? Yes. But when it comes to the real packet on the network, this is what we have. Yeah, we have the source IP and then this. But whatever that you're saying here, it's not a message that is going to. This is part of the encapsulation, the packaging. This. Then the message size, when you look at this figure that we have here, we have one complete thing, this, and it's not allowed because it's too big. So to be allowed on the network, it means that the receiver cannot manage this, cannot handle this. But when it comes to the second one here, now the receiver can actually manage the bits. That's the reason why you're seeing the segments, see? The segments. So the two, they have to agree. Then we have message timing. Message timing includes the following. Flow control manages the rate of data transmission and defines how much information can be sent and the speed at which it can be delivered. Then we have response time, manages how long a device waits when it does not hear a reply from the destination. Then we have access method, determines when someone can send a message. So there may be various rules governing issues like collusion. So this is when more than one device sends traffic at the same time and the message becomes corrupt. So some protocols are proactive and attempt to prevent collusion. That if it detects that there is a collusion, it is prevented. Other protocols are reactive, and establish recovery method after the collusion. That the message that was sent, it can be resent again after the collusion. We talked about the delivery option. That is where we have things to deal with unicast, multicast, and then broadcasting. Multicast, unicast, broadcast. So broadcast, it's one to all. Multicast, it's one to many, typical, but not all. And then unicast, it's one to one. And the figures are here. As you can see, it's this to one. This is unicast. We have multicast, which is one to group, and then we have broadcast, it's one to all. So the same here, as you can see, unicast, it's one to one, then one to many, that is multicast, and then one to all as the broadcasting.